Let's talk about tropics. It's been a relatively quiet season, fortunately, but we have something brewing out there, and it's headed into the Gulf of Mexico, which right now is a little alarming. And there's been a lot of buzz about Helene as well because of those sea surface temperatures in the Gulf of Mexico. So, can you tell me where we kind of stand right now at this point in the year when it comes to the warmth of the Gulf?
Yeah, the Gulf of Mexico is at record warmth right now. We haven't seen sea surface temperatures and especially as much heat content. That is how much heat the Gulf of Mexico is holding. We haven't seen this much in the historical record for this time of year. We're kind of running near the record of all time a few weeks in advance. And so we're kind of surprised by that. It is very warm out there, a lot warmer than we would expect. And then that, of course, begs the question of why is it so warm and how does that matter for hurricanes? So excited to get into that a little bit more. But
Yeah.
we know that this warmth is relevant because storms care a lot about how much energy they can sort of pick up from their surroundings.
Yeah, can you give me any sort of idea of like what numbers we're talking about? And I know it's hard to get into specifics because it's so different depending on where in the Gulf you are, and then also like depth, because that matters too, right?
Yeah, so when I'm talking about the influence on hurricanes, I tend to think about sort of the topmost layer of the ocean because that's the layer the hurricane sees first and kind of is interacting with. We're seeing temperatures that are something like 2 degrees Celsius or almost up to 4 degrees Fahrenheit warmer than they would be normally this time of year, which is really dramatic and is kind of it's like if we took the hottest ever October and we moved it into September, and that's what we're living right now. It's not only extremely hot, it's also unseasonably hot, and so we're just seeing things that are sort of it's difficult to put into words because these are numbers we haven't really seen before. 4 degrees Fahrenheit warmer. You can imagine that if in your body you ran a 4 degree fever, you jumped up to 102 degrees Fahrenheit. That would be extremely challenging. Your body would react to that, in a bad way. And it's the same way with these hurricanes. They see that increase in temperature, which doesn't sound like a lot, right? But it's a lot of energy that is all across the Gulf as a result of these warm sea surface temperatures. And so it really is quite dramatic. And we broke the record last year for how warm the sea surface temperatures are in the Gulf of Mexico. And this year we're going to be breaking the record almost certainly again.
Okay, and then I think what's alarming too about this is what happens right before landfall, and we saw it. I feel like a few times last year. This rapid intensification. So, is that part of the difficulty in forecasting this? Is that this could go from something a little weaker to all of a sudden a really strong hurricane right before landfall, and perhaps even in like the middle of the night when people aren't really as prepared?
That's right. So we saw with Hurricane Beryl before it hit the Lesser Antilles, this storm started at like a tropical storm, then Category 1, and it jumped all the way up to Category 4 overnight. This can happen with storms. We call this rapid intensification, as you mentioned before, and we found that this rapid intensification behavior correlates really strongly, or is connected and linked really strongly through the science to how warm the sea surface temperatures are. So if your sea surface temperatures are really warm, like we're seeing out there in the Gulf right now, there's just a higher chance that you'll undergo this rapid intensification process where you can go from a very low intensity to a very high intensity. Now, the math and the physics kind of underlying this rapid intensification process are really complicated. For a really long time, we were good at predicting, where a storm is going to go, the track, like where is it going to make landfall. We're still pretty good at that, but we've been getting progressively better at sort of one of the weaker aspects of our prediction, which is how intense the storm is going to be at landfall. We're getting better at understanding the conditions that lead to high intensities, but it has still some sort of outlying uncertainties. And so it's difficult to say whether a storm will be very intense at landfall or not quite that intense. We don't know in the beginning, but we do know that the conditions are right for it to undergo rapid intensification in the case of Helene and many of these other storms as well that are sort of living in these very warm sea surface temperature environments.
Okay, so I'm curious too, do higher sea surface temperatures influence certain impacts of the storm more than others? Like, say, is there more rainfall or more storm surge or stronger winds or all of the above?
Yeah, that's a great question. So all of these things are linked within a storm environment. The amount of rain that is coming from the storm is sort of picking up moisture from the ocean surface, which is going to pick up more moisture when the temperatures are warm. And that moisture is also going to sort of be wrung out of the storm more effectively, almost like when you wring out a sponge, if you have a stronger wind speed. That stronger wind speed can cause more wind damage. It can also bring on shore more water in the form of storm surge. So all of these things are connected through to how intense the storm is and how much water it sort of is carrying along with it. We can influence this in a variety of different ways. In the case of the sea surface temperatures, we know that hurricanes tend to be able to spin faster if the sea surface temperature underneath them is quite high. That's what we're seeing in the case with Helene, where there's these really high sea surface temperatures. So there is a sort of propensity, a likelihood that the storm will spin faster than it otherwise would because the sea surface temperatures are higher. But it can also lead to sort of more rainfall coming out of these storms because sea levels are higher. Through climate change, we know that there's more water available to the storm to bring on shore. Because there's more water in the atmosphere, as temperatures of the planet goes up, the amount of water in the atmosphere all around us right now is actually increasing as well. And that means there's more water just available to these storms to rain out to begin with. So all of these influences can play a role in sort of the damages that a hurricane brings on shore. And in many cases, with the exception of maybe changes in where storms are falling, sort of, or making landfall preferentially, there might be some shifts in that. But in the absence of any shifts in where the storms are making landfall, when they make landfall, they're in general doing more damage than they would have been, say, 100 years ago.
How does Climate Central link these sea surface temperatures to climate change? How does that attribution science work?
Yeah, so you can think of the set of sea surface temperatures that we're experiencing in the Gulf of Mexico right now. That's the world in which we live, right? We can see how warm the sea surface temperatures are. You can ask this question: what would those sea surface temperatures have been in a world where we hadn't emitted greenhouse gases and aerosols into our atmosphere? How much colder would those sea surface temperatures be? So we use a mixture of observations, that is, the things we're actually measuring in the current real world, and the trends in those observations over time. We use those in concert with a variety of climate models, which we can run with and without those chemicals in the background of the model and see how the ocean evolves. So with a combination of the model estimates of what the sea surface temperatures would have been in a world without human-caused climate change, and the observations telling us what the trend in the world has been over the last 50 years or so, we can use both of those to start to pinpoint the set of temperatures that we would expect in a world that was cooler because human-caused climate change wouldn't exist in that world. And so we compare the set of temperatures we have now to the set of temperatures in this hypothetical world without climate change, and we see that the temperatures are something like 2 degrees Celsius or maybe 4 degrees Fahrenheit warmer in the Gulf of Mexico. And so that really does show that, we find this both with the observations and with the models who are using different methods to sort of arrive at the same conclusion, that the sea surface temperatures are quite a bit warmer than they would have been if we hadn't been if we hadn't been interfering in our climate system in the way that we did after the Industrial Revolution.
So, what does this mean for the rest of the season? Are these water temperatures going to keep getting hotter?
That's a really hard question to know the answer to. We know that the water temperatures that we have are hot right now. And so there is a higher chance that we're going to continue to have warm sea surface temperatures throughout this season. That's almost certain. The degree to which it influences individual storms is challenging to say before we actually see it happening. But we know the environment is ripe for extremely strong hurricanes. And it really just depends on whether or not the rest of the things that influence hurricanes, whether that be moisture content and wind shear especially, and stability of the atmosphere. If these things sort of cooperate and we get a hurricane, it's not going to really have any upper bound to which it can grow. It can really strengthen quite dramatically because the sea surface temperatures are really warm. Hurricanes are almost like the engine in your car. As you sort of add the amount of fuel that you have, any amount of available fuel that you have to the storm, you can imagine pushing the accelerator down on your car and the engine spins faster and faster. Well, when these hurricanes encounter these warm sea surface temperatures, it's like pushing the accelerator down. And we do see many storms start to spin up quite dramatically. And we expect this is going to be the case with these sea surface temperatures as well. If we get a storm that kind of sets up, it's going to have a lot of fuel to be able to strengthen. And we expect, people should pay close attention to any storms that sort of are out there in the environment, because these storms can rapidly intensify given the warm conditions that are out there.